So our first opportunity to find a limit, the first thing we always want to try when finding a limit is just substitute in the value that we're taking the limit as we approach, right? Just plug in for x. But sometimes that doesn't work and we need some different algebraic techniques to kind of manipulate that and figure out what the actual limit is. These are especially useful when you don't have a graphing calculator with you or you're not allowed to use a calculator or something like that. So the first thing we're always going to do is check to see if we can't substitute, which I'm going to tell you we can't because I wrote these problems specifically so you couldn't, but we're going to check anyway, right? We could do this by hand for this one. We don't need a calculator, right? So if I plug in, right, 4 cubed minus 64 is 0, right? Because 4 cubed is 64, so 64 minus 64 is 0. If I plug into the bottom, I get 4 squared is 16 minus 4 minus 12. Okay, that's also going to give me a 0. So this gives me a 0 over 0, and that's called something called an indeterminate form. So 0 over 0 doesn't necessarily equal 0. It means that something tricky is happening behind the scenes that we need to manipulate so that way we can see what's actually going on. So when we have polynomials, we want to factor. So we're going to keep our limit notation because I haven't taken the limit yet. Right, we're going to keep writing this until we actually can plug in. So let's factor the denominator first because that's a little easier. So we want to multiply to negative 12 and add to negative 1. So that's going to be negative 4 and positive 3. Now in the top, I have a difference of perfect cubes, right? I can rewrite x cubed minus 64 to think of it as x all cubed minus 4 all cubed. So this is when I'm going to use something called the SOFAS pattern. So that's a little acronym I use in my Algebra 2 classes to help teach this. So the first parenthesis set is going to be you take that stuff and drop the cube. So I'm going to get x minus 4. And then for my second parenthesis set, I'm going to use SOFAs. So the first S stands for square the first term. So I got x, I'm going to square x, so x squared. O stands for opposite sign. I have a minus sign, so opposite is positive. F stands for front times back or first times second, however you want to think of it. So I have x times 4, so 4x. A is always positive. S is square the second term, so 4 squared is 16. So now I can get rid of that common factor. I'm going to keep my limit notation because I still have not taken the limit. But now that I've gotten rid of that common factor, that's what was causing the 0 over 0 portion. So now I can just plug in with my 4. So if I plug in 4, I no longer need limit notation because I'm taking the limit. So I'm going to get 16 plus 4 times 4 is 16 plus another 16 over 4 plus 3, so 7. And then 3 16ths is going to be 48 all over 7. And that'll be my final value there. Now my second problem looks like a monster, and I want to show you this because I want to show you some different factoring techniques. So if we go over here, we need to figure out, first of all, if we plug in negative 1, will this give us a 0 over 0? And I don't feel like doing this arithmetic by hand, so we're gonna not. Let's just put this over here. Okay, so I'm gonna plug into the top first. So I've got negative 1 raised to the 4th, right, minus negative 1 raised to the 3rd, minus negative 1 squared, minus 3 times negative 1, right? And if you can simplify this in your head, like that's not too bad. So we do get a 0 in the top. And then notice I'm not writing equals 0 over 0. You never want to write that. And then in my denominator, I have 2 times negative 1 squared minus negative 1 minus 3, right? We also get a 0. Right, so because it's a 0 over 0, we know that it's going to be indeterminate and we have to factor. So I'm going to factor the denominator first because that seems a little bit more manageable. Okay, just going to put my 0 over 0 off to the side, give myself some little bit more space. So when I want to factor the denominator, right, my a times c value here in my quadratic, right, 2 times negative 3 is negative 6. Then I want to add up to the negative 1, the b term in the middle. So if I use negative 3 and positive 2, that will work. Now, I like to factor things in my head. That might be different than you do it, but I'm going to talk you through my thought process. So if I want to factor the denominator, I know it's a quadratic, so it's going to factor into 2 different portions. So I know I want to get a 2x squared back, so I have to have a 2x and an x. So if I want to be able to multiply and get a positive 2, I need to have 2x times positive 1 here, and then I'm going to get minus 3 on the other side. I can also factor this because I know that when I plug in negative 1, I get a 0 in the bottom, and that means I have to have a factor of x plus 1. So that's another way to get it. Now I want to factor the top. So I know the x plus 1 here, that's the problem. But I have a 5-term quartic polynomial at the top. I don't know how to factor that. Like, you can't just split the middle and do factoring by grouping. It's a mess. So I'm going to be a little tricky about this, and I know, right, I know that because this negative 1 is a problem, I know that there's an x plus 1 in the top. I just know it, right? Because something's going to have to cancel out because these are just polynomials, so it's just basic factoring stuff. And I drew way too long of a line here. Let's deal with that nonsense. So what I'm going to do is I'm going to use synthetic division to take out that positive 1. So for my synthetic division, I'm going to put negative 1 in the box, and then right, starting with x to the 4th, I have 1x to the 4th, negative 1x cubed, negative 1x squared, negative 3x's, and negative 4 constants. Right? We're just going to divide, so bring down the 1 and multiply, add down, multiply, add down, multiply, add down, multiply. So that's going to leave me with x cubed minus 2x squared plus x minus 4. So that's going to be my other portion. Right, so you have all of those algebra tools at your disposal. You just have to remember them and know how to appropriately use them. So now I can cancel out that common factor of x plus 1. And so now I'm just taking the limit as x approaches negative 1 of x cubed minus 2x squared plus x minus 4 over 2x minus 3. And now I'm in a place where I can plug in with negative 1. So, right, if I do that in the top, negative 1 cubed is negative 1, negative 1 squared is positive 1 times negative 2, right, minus 1 minus 4 over negative 2 minus 3. So I'm going to get negative 3, negative 4, negative 8 over negative